Advanced Algebra Chapter 13 Lesson 2, and we want to wrap this lesson up by looking at the sine and cosine of these angles in the unit circle or in the coordinate plane, and then sine and cosine of coterminal angles. And again, I'm going to use a pre-calculus video. In the video, I will talk about other trigonometric ratios, tangent, cotangent, secant, and cosecant. We will not cover those in this lesson. We will only cover the sine and cosine ratios, but the method that we use to determine those is the same for determining those other trigonometric ratios as well. So as you watch the video, take note of how we draw the reference triangle, how we determine the angle measure, how we label the sides, and then write the sine and cosine ratios for this chapter and this lesson. Chapter 4, Lesson 3 of Pre-Calculus, and again we want to tie something that we've learned before into what we're learning about these coterminal angles, and that is the special triangles we looked at, the 45-45-90s and the 30-60-90s. And the connection can be made with these coterminal angles and what we were talking about in the last video, where if we have a point in the coordinate plane and we draw a line through that point and we draw a reference triangle, then this theta, the sine, the cosine, the tangent, all of these trigonometric functions for this angle from here to here are going to have the exact same value as any angle that's coterminal with it. So this theta, if we took theta and we added 360 to it, and came all the way back around, the sine, cosine, tangent, the 6 trigonometric function values would be exactly the same as this theta if I were to calculate the 6 trigonometric functions for this angle here. And then if I went around again, they're the same. And then if I went again, they're the same. Or if I went around again, they're the same. Or if I went the negative direction, they're the same. Or the negative direction, they're the same. And you just keep going around and around and around. And as long as you stop here, the 6 trigonometric ratios are going to have the exact same value as this ratio as this angle from here to here. So knowing that, if we are given an angle whose coterminal with one of our special right triangles, we can calculate the 6 trigonometric ratios using those special triangle ratios. So let's say I asked you to give me these 6 trigonometric function ratios, so all of the trig ratios, for an angle that's 315 degrees. Well, if I was to draw the 315 degree angle in my coordinate grid using, this is my initial side, and then rotating 315 degrees, starting here, this would be 180, this would be 270, then some more in here. So this would be my 315 degree angle. Now, if I determined what this angle was and I drew a reference triangle, I could calculate those triangles or those ratios. Now, if I take 360 minus 315, it turns out that this angle right inside here is a 45 degree angle. And because it's a 45 degree angle, this is a 45-45-90 triangle. Therefore, if I make this 1 and this -1, because the y value is negative, then I know this is radical 2. I can write all of my trig ratios based upon what I know about the 45-45-90. So the sine of this 315 degree angle is going to be 1 over square root of 2. The cosine of this 315 degree angle is 1 over the square root of 2. And the tangent of this 315 degree angle is the -1 over 1, which is -1. And then again, the reciprocal function, the cosecant of this 315 degree angle is the reciprocal. The secant of this 315 degree angle is the reciprocal, and my Starbucks is here. And the cotangent of this, I'm getting all excited about my Starbucks. My cotangent, I'll get it, stop right there, 315 degree angle is -1, or 1 over -1, which would be -1. So you can see, if this angle relates to one of my special right triangles, I can plot it in my coordinate grid, draw my reference triangle, use the sides that I know, and write my ratios very quickly. So we can connect what we know about 30, 60, 90s into these coterminal angles that we're talking about, because any angle that has this as its terminal side, the ratios are going to be the same no matter what the measure of the angle is. A few more examples of finding the sine or cosine of a given angle. As we look at this angle here, we're asked to find the sine of the angle. The angle is a 330-degree angle. This is the terminal side. I draw a line perpendicular to the x-axis, creating my triangle. Then I need to determine what the measure of this angle is in here, and we're working with 30, 60, 90 or 45, 45, 90. Once around the circle is 360. This is 330, so if I subtract those two, that tells me that this is a 30-degree angle. Once I know that that's a 30, I can then set up my sides. This opposite of the 30 is a 1, but because it goes down, it's a negative 1. This would be a square root of 3, and then the hypotenuse is a 2, and then I simply write my ratio. The sine ratio of the 330-degree angle is the opposite side, which in this case is negative 1, over the hypotenuse, which is 2, so the sine of a 330 is negative 1/2. Another example here, sine of 60. This is a 60-degree angle. I draw my line to the x-axis. This is a 60-degree angle, so opposite the 60 is the square root of 3, and it's positive because it goes up. This is 1 and this is 2, so the sine then would be the opposite side, square root of 3, over the hypotenuse, which is 2, square root of 3 over 2. A couple of more examples here. This is a negative 390 degrees, so this terminal side has been rotated in the clockwise direction. Once around the circle is 360, and so I'm 390, that's 30 more past the 360. So again, this is a 30-degree angle. Opposite the 30 is a 1, and because I go down, that's negative 1. This would be square root of 3. And then this is a 2, so we're looking at the cosine. The cosine is the adjacent side, so in this case it would be positive square root of 3 over the hypotenuse 2, so the cosine of this angle would be the square root of 3 over 2. A final example as we look at number 8. Now this is a 600-degree angle, so we go once around the circle, that's 360 degrees. We go half a circle here, so this is another 180. So how much is this? Well, if we take 360, and then that's once around the circle, and then we add 180, that's going to give us 540. So 540, this many more to get to 600 would make that a 60-degree angle in here. Opposite the 60 is the square root of 3 length. It goes up, so that's a positive value. This would be 30. Opposite the 30 is 1, but because we went left, that would be a negative. And then we have the hypotenuse of 2. Now we can write the cosine. The cosine is the adjacent side, which in this case is a negative 1, over the hypotenuse of 2. So the cosine of a negative 600-degree angle is a negative 1/2. Okay, so to write the angle or the sine or cosine of an angle, we need to draw a line vertical to the x-axis, determine the measure of the angle now that's inside the triangle, and we're only working with 30, 60, 90s or 45, 45, 90s. Once we have that reference triangle drawn, we label the sides using our knowledge of the 30, 60, 90s and the 45, 45, 90s, and then making sure, that if you are going down, the value is negative, or if you're going left, the value is negative, and then you write the ratio using the trigonometric ratios.